All right, guys. Last one for the year. And then we just have finals next week. So we are here on circles. It is going to be a difficult test tomorrow. There's just a lot of stuff to remember. I know that the majority of teachers are going to be giving you some kind of not really a cheat sheet, but like a formula sheet and stuff to help you guys out. So there will be that because there is a lot of stuff with circles. So let's get started. All right, we want to find the area of the sector and the arc length. And I've identified the sectors here by the shaded area. Remember, anytime we're doing area of anything, you need to have units squared. So your answer for area will be centimeters squared. This one, it'll be meters squared. So you just need to make sure that whenever we do anything with area, it's going to be the units squared. Okay. And instead of memorizing a formula for this, I think you guys already know that the area of a circle is pi r squared. That's if we wanted to find the whole circle. We just want to find this little piece. And this little piece is 80 out of the 360 degrees. So yeah, it's useful to memorize a formula to do whatever we need to do. But if you think you already know the area of the whole circle, and the whole circle is 360 degrees, we just want a little piece of it. We want 80 degrees of that, so we can just go about it that way. You are going to be given calculators on this exam to calculate this kind of stuff. We know our radius, it's 6, so I have this part right here. That's what we're going to be doing right there. So 80 over 360 times pi, and then 6 squared, which is going to be 36. So I've got 36 pi times 80 over 360. Depending on how your teachers ask you to leave it, I'm not sure which way it's going to go, but I'm going to go 80 divided by 360. It's going to give me 0.222222222. I'm going to multiply that times 36 pi, and that's going to give me 25.13. 25.13 centimeters squared. Okay, so that's area. Arc length. We want the distance from here to here. So if I'm standing here and I'm walking this distance, that's what I want. That is not 80. I know you guys learned that central angles, this is 80, then this little piece here is 80. And that's true, but this whole thing is 360. So that's why they correspond. Right now we're looking for an actual distance from here to here. So that's arc length. And to find your arc length, you're going to use circumference. So your circumference formula is 2 pi r. And you guys used that before when we did surface area and lateral area. So we have 2 pi r for circumference. And again, we're just going to use a piece of it. So it's 80 over 360. So we're just using that piece. That's the piece we're using because that's what we're given here. That's the only piece we want. We know our radius right there. That's going to be 6. So over here I've got 12 pi times 80 over 360. I'm just going to multiply all that out. 80 divided by 360 again gets me the 2222222 times 12 pi. And my answer is 8.377, 8.38, 8.4, depending on how many decimal points you need to use, but we can use 8.38 for that. And again, that is centimeters. That's how far this guy had to walk from here to here. All right. Second one, same thing. We're finding area, we're finding arc length. But this time I want the area of this big piece over here. You're going to do it the same way. So we've got pi r squared. That's the whole piece, which is 25 pi. So remember I went pi r squared. Just plug that in. That's how I got 25 pi. And I've got 300 over 360 this time. So let's multiply all that together. Again, you're given a calculator for this exam. And you're going to multiply that times 25 pi to get you a grand total of 65.45. If you round to the 10th. or the hundredth, see where you're at with that. And that is going to be meters squared. Remember area, don't forget your units. Arc length, okay, we've got 2 pi r, and then we're going to have that times 300 over 360 again. I know that's 5, so I'm going to multiply those together. So I've got 10 pi times that. Clear. 300 divided by 360, it's me that, times 10 pi for 26.18. 26.18 meters. Right, so that is area of a sector and arc length of the same sector. Okay, those are the two you'll need. And again, I wouldn't think about it as trying to memorize a formula. I would look at it more holistically. You know the area, again, for the whole circle is pi r squared. If they just want a piece, just take the piece of it over 360. All right, here's where things get a little uglier because we are dealing with all these different types of circles. What are we looking for? What are we trying to find? Are we inside, outside the circle? So when I approach problems like this, I always kind of like to figure out what I have. And so for this circle, I'm looking for a length. I'm not looking for an angle measure. I'm looking for a length. And what am I given? I'm given 2 secants. So I have 2 secants. I'm looking for a length. And what I'm going to do is I'm going to multiply. And I'm going to multiply the outside by the whole. So the outside piece is 4 times the whole piece, which is 4 plus 12, that's 16. So multiply the outside by the whole, and I'm going to set that equal to the same thing on this side. The outside times the whole. And I don't know what the whole is, but I know it's 5 plus x is going to get me this whole thing. And now I'm just going to solve for x. So I get 16 times 4, which is 64, equals, make sure you distribute to both, 25 plus 5x. Subtract 25 to both sides. Again, it's completely appropriate for you to get some kind of fraction or decimal. Not going to be a problem because we're looking for a length. Let's subtract that. I'm going to get 39 is equal to 5x. When I divide both sides by 5, x is equal to 39 over 5. Leave your answer like that. You do not need to convert it into a mixed number, but you found that length right there. Okay, number 4. You're also looking for a length, right? But we are inside. Everything is contained inside the circle. I hope you guys can see the difference between, like, there's stuff going on outside the circle here. Everything in here is contained inside the circle. So inside the circle, we're just going to go each piece and multiply them and set them equal to each other. So I'm going to go x times 2 is equal to 4 times 7. So 2x equals 28. Divide both sides by 2. X equals 14. Okay, so this piece right there is 14. And like I said, I'm not sure how each teacher is going to go about giving you guys formulas or a little bit of help on this stuff. But, you know, a lot of these things do have formulas for them. They're not very helpful sometimes because they'll just label these A, B, C, D, E, and then they'll say AB times this is equal to this times this, but it'll be easier than trying to memorize everything. Okay. All right, number 5. What am I looking for? I'm looking for an angle, right? Here I'm looking for angles. So I have to take a different approach. I'm looking for angles and everything is inside. Everything's inside, okay? So I'm finding the measure of an angle and everything's inside. So the way I like to look at this is I'm going to use these arcs. This is my arc 1 and my arc 2. I always like to call my bigger arc, arc 1, my little one, arc 2. But to find an angle, I kind of write it out like this. Angle is equal to arc 1 plus arc 2 divided by 2. And that's what I'm looking for. So I've got the angle, which I'm just going to call x, is equal to arc 1, 175, plus arc 2, 55, divided by 2. That will get me 230 divided by 2, which will give me 115. All right. You can use a calculator. You'll get a calculator for this, but sometimes I feel like you're not thinking very much if you do the easy math with a calculator. Okay, this guy here, you're also looking for an angle, but your angle's outside. We're outside the circle again. All right, so we have to do a different formula. Okay, it's similar to this. We're just going to change this to a minus sign. So your angle is equal to arc 1 minus arc 2 divided by 2. Right? So angle equal to 140 minus 30 divided by 2, which gets me 110 divided by 2, which equals 55. So this guy right here is 55. Number 7, don't overthink it. It's just an inscribed angle. So an inscribed angle is an angle that comes across, it hits the outside of the circle, and then comes down twice. The easiest thing to know about the inscribed angle, I'm going to write it in here, this is inscribed, is that the angle is equal to half of the arc. So the arc is 250, the angle is half of that. So we've got 2 into 250 is going to give me 1. I'll do it the long way for you. 25. So I got 125 for my inscribed angle. Number 8, I wrote that AB is a diameter because my line drawing was a little bit off. But if it's a diameter, it cuts a circle in half. If it's a diameter, it also means that this whole thing right here has to equal 180 degrees. The whole circle is 360. Half of it is 180. So if this guy is 35, this guy right here is just 180 minus 35, which is going to give me 145. So this guy right here is 145. Okay. Going back to parallel lines, when you guys did this, you did straight lines like this. It was just 180. It's a linear pair. Look at it like this. If I turn it upside down and show you guys and take that off, you just have your linear pair. They're adjacent. Super easy. All right, number 9. Okay, so here's where we get another formula. All right, this one is a tangent and a secant. And again, I'm looking for a length. And what we're going to get is the tangent. This is your tangent piece. This is a little piece because if it's the one that actually hits the outside of the circle just once. So it's the tangent squared. So it's the tangent squared is equal to the outside piece times the whole piece, which is 4 plus x. Okay, the tangent squared, the little piece times the whole piece. So let's do that. 36 equals, make sure you distribute to both, 16 plus 4x. I'm going to subtract 16 to both sides. I have 20 is equal to 4x. Divide both sides by 4. X equals 5. Okay. Number 10. 10 I like. We're going to say that this guy right here is a tangent. This guy right here is a tangent. Might not look like it. I know I should have told you guys right here, like anything that looks like a tangent is a tangent, just to help with my poor art. But when you see these, anytime a tangent hits a radius, so when the tangent hits the radius, you get 90-degree angles. Okay? When a tangent hits the radius, you have 90-degree angles. And that is important because that makes this next part super easy. If I look at this, I'm looking for this whole angle value here. if I look at this whole thing, I have a quadrilateral. I have a four-sided figure. And I know that the degrees in a four-sided figure are 360. If you didn't know that, they are. So now I can just add up all my angles and figure out which this is by subtracting it from that, from 360. So I've got 100, 90, and 90, 100, 90, and 90, which gets me 280. I'm looking for this guy. He's the leftover. So let's subtract. And I've got 80. So this guy right here is 80. Sometimes they break this in half like this. Let me grab another color. Sometimes they cut this in half, right? If they cut it in half, it's actually just a little bit more fun because you have two triangles and this will be a bisector. And you actually have two right triangles that are congruent. So don't freak out if you see it cut this way and they only want a little piece of it or whatever. You've got two congruent right triangles. They're congruent by hypotenuse and leg. You guys see they share the hypotenuse. Their legs are the same because they're each a radii. So those would be the same. These are bisectors. It's pretty cool. So don't freak out on your test tomorrow if you see it cut in half like that. Just know they're triangles. You can do 180 degrees if you just wanted to look at just little one piece of this, like that. So there are a lot of ways to look at that problem. All right, number 11. All right, I have two tangents on the outside of the circle. Two tangents on the outside of the circle. All right. If this piece right here is 100, got this piece right here at 100, then the rest of this whole thing has to be 260. Okay, and then I'm back to doing my minus because I'm outside. So I have the angle equals arc 1 minus arc 2 divided by 2. It's cut in half, it would be 80. No, if it was cut in half, it would be 40. We would cut each one in half. That's for the whole angle. I just cut it in half because some of the review questions on some of the teachers they did it into triangles instead of leaving it as a quadrilateral. All right, so we've got 260 minus 100, which gets me 160 divided by 2 is going to give me 80. Okay, so this guy right here is 80. Is that the one you're talking about? Or are you talking about the one before? Let me know. Okay, 12. All right, so this one's fun. We're doing the same thing. We're outside, but this time we need the arc. Okay, so I'm going to go off of this same thing where my angle is equal to arc 1 minus arc 2 divided by 2. This time I'm looking for arc 2. All right, so let me just plug in what I have. 72 is equal to arc 1, which is 200, minus arc 2, all divided by 2. Now, how you go about solving this is however you want. This arc 2 is actually just another name for that, would just be x. That's just our x right there. Okay? So I like to fraction bust. I like to get rid of that fraction. So I'm going to get 144 equals 200 minus, and I'm just going to plug that in, and I'm going to call him x. And I know that my x is my arc 2. I'm going to subtract 200 from both sides. And I'm going to get 56, negative 56 equals negative x. And then x equals 56. So I just divide out by the negative 1. Okay. All right, so those are all the types of circle problems you're going to get. It's a lot, I know. And the only way you can get better at it, honestly, is to practice and make sure that you kind of understand the properties, understand what you're looking for. Am I looking for an angle? Am I looking for an arc? Am I looking for the length? What am I looking for? All right, these are your review questions. There are special right triangles. So this one right here, this is your 30, 60, 90 triangle. This one's your 45, 45, 90 triangle. So if you remember, in your 30, 60, 90 triangles, the way we like to look at it is 30 is x, whatever's opposite of the 30 is x. The hypotenuse is 2 times that. And whatever's opposite the 60-degree angle is x rad 3. Right? So when I look at this, I'm given opposite the 90. I'm given the hypotenuse. So this one is the doubled one. So I could just solve that equation, or I could know that opposite the 30 is half of it. This one's half of this one. So I've got, this is 10, which makes opposite the 30, 5. And if this is 5, then it makes opposite the 60, 5 rad 3. Easiest way to do these, honestly, just to memorize. Okay? X, 2x, x rad 3. For the 45, 45, 90, it's x, x, x rad 2. So how do I know it's a special right triangle? One, I have a right angle. I have these ticks right here, which show me that it's isosceles. So I know that this and this are the same. So if this is 5, that guy right there is 5. And when I'm doing this, this guy is just 5 rad 2. Now, let's say you didn't remember that. If you didn't remember that, on this one, you could easily just use the Pythagorean theorem. 5 squared plus 5 squared equals c squared. You could do it that way, but it's always going to work out the same for isosceles triangles. Remember, it's x, x, x rad 2. And then your other review questions, volume, surface area, lateral area, finding more volume. So I'm going to go ahead and leave all these in pi. I don't know what the answers are going to look like. I know these are usually multiple choice questions on your exam. So like I said, you're given a calculator. So if it's approximated out, then you're good to go. So you got to do the volume, okay? And the volume of a cone is 1/3 pi r squared h. Okay, 1/3 area of the base times the height. I'm not given the height, but because you guys are all super smart and you already know this and you've seen this 100 times, this is a 3, 4, 5 triangle. I'm going to need this, which is my slant height. It's my slant height. I will need that to find surface area and lateral area. Okay, so let's find the volume. 1/3 pi r squared h. My radius is 3. I'll come down here and do this. So volume is equal to 1/3 pi 3 squared times 4. I get 1/3 pi 9 times 4. 1/3 pi times 36. Okay, and 1/3 of 36 is 12 pi centimeters cubed. Don't forget your units. Okay, don't pick the wrong one because one says squared and one says cubed. Okay, volume is in cubed. Surface area is pi r squared, because you have the area of the base, plus pi r slant height. Okay, pi r l for the slant height. All right, this guy right here, that's your lateral area. Add them together, you get your surface area. So plug in, I've got 9 pi, that's 3 squared. And here I've got 3 and 5 plus 15 pi for the grand total of 24 pi centimeters squared. That's my surface area. My lateral area is just 15 pi centimeters squared. Okay. And then they always like the volume of square pyramids. And I'm going to put that in inches just so that we have it there. Square pyramid means everything is the same at the bottom. And the volume, I'm only finding the volume. It's 1/3 area of the base times the height. Area of the base of a square is length times width. So let me take care of that. 6 times 6. So I've got 1/3 times 36 times 10, right? You do get a calculator, but a third of 36, that's like 36 divided by 3, that's 12, times 10 gets me 120 inches cubed. So I'm doing volume. Remember, volume is units cubed. Surface area and lateral area are units squared. All right. And that's it. It seems like that's it, but I know it's a lot. So on your exam tomorrow, here's what we've got. We have a total of 12 questions. We have 12 questions, one of which is extra credit. So actually 11 questions. Right? You have 1, 2, 3, 4 review questions. So of those 12, 4 review. You have an area of the sector problem and the length of a sector. So you have one problem with that, 2 parts. You will have inscribed angles. You'll have, let's see, you'll have a question that kind of looks like, well, basically, you're going to have one of these, one of these, one of these. The length of the sector was up here. You're going to have one of everything on this test. I think that's why there's so few questions. I only had, I think, 12 different types of questions, 12 circles, and I kind of did 2 of each. So you're going to have one of each. Finding the length of the sector is right here. So again, the length of the sector is circumference. You're given a circle. All you need is the radius, okay? You need the radius and you need how much you need to look for. So if this is 25, say that's 25 degrees. Oh, let's say that. Say the radius is 3, and we'll say that this angle in here is 25, right? So you're to find the length of the sector. This is length of sector. It's 2 pi r. You're looking for circumference. So you have this, and it's going to be times whatever sector you're given. And in this case, it's 25. So you got that. You got 2 times pi times 3 times 25 over 360. That gets me 6 pi times 25 over 360. And then plug and chug, my friends. 25 divided by 360 equals that times 6 pi. So my length is 1.3, whatever the units are. So 1.3, we'll call it centimeters squared. Other than that, that's it. So I would just review questions like this. I know that you've had a couple different review sheets that have all these different types on it. I know it's not easy. I know it's like which one is which one's that. So I like to kind of memorize them as stuff on the outside and stuff on the inside. And I kind of like to split them up that way. I also like to split them up. Am I looking for lengths like this and like this? Or am I looking for angle measures like this and like this? So I kind of think of it as inside and outside, and then angle measures versus lengths. And then I go from there. All right, and that is all I have for you, my friends. So again, tutoring tomorrow. At lunch, I can tutor at lunch in 110. Before school, C. Finch, he's in 107. Okay. Not good luck tomorrow. This will be our last exam before the final, and don't forget your final will count, will replace your lowest test score. So you guys have done a great job so far this year of all these exams. It's a lot, I know. So good luck tomorrow.